Welcome back. In this video, I'm going to look to modify the integer chip method so that it can be used with larger numbers. So this method is a method that I've just recently come across due to my mentor, and it is called the T-chirp method. So we'll look at a couple of examples, just like we did with the integer chips. So let's start with 5, take away 7. In the integer chips, we had students draw 5 positive chips, and they knew they needed to take away 7 positive chips, so they had to add 0 pairs. The T-chart method, we're only using numbers. We create a little chart where we keep track of our positive numbers on one side and our negative numbers on the other side. We start by writing down the first number, and since we're taking away, this is the only number we need to write down, because we're not adding, we're taking things away. So because I have to take away 7 and I only have 5, I can take away the 5 and left over. There's nothing left over, but I know I still need to take away 2. So in order to be able to take away 2, I have to put a 2 on both sides, just like we did in 0 pairs. So then I will take away these positive 2's, because I have to take away positive 7. You can see that I've taken away positive 7. And on this side, I'm left with a negative 2. So my answer here is negative 2. Let's try another example. So let us say we have another small number. Let's start with small numbers that could have been represented with integers. So we'll have 9 take away 12. Again, this is a common pitfall where students will try to rewrite this as 12 take away 9. So one of the issues that has been identified is that students need to keep track of their positive and negative numbers. So again, we're going to put down the chart. All of our positive numbers go on this side, negative numbers go on this side. Start with 9, and I need to take away 12. So I can break this 12 up into groups that kids are comfortable with. So we know we need to have 1 on each side, negative pair, 0 pair, because we can add, just like it's in integer chips, we can add as many 0 pairs as we wish. Because when we add a 0 to anything, it doesn't change. So if I add a +1 and a -1, it won't change this value. So that would only get us to 10 on this side. And now I need 2 more to get to 12. So now I'm able to take away 12 positives. And on this side, I have 3 negatives left. So the answer, 9 take away 12, is -3. Now let's try larger numbers, because this, students could still be able to do this expression using integer chips. It wouldn't take too long. But let's say we have a number such as 34 take away 56. Now this becomes more tedious and timely to do using integer chips. Let's see if it works with our T-chart method. So I have 34 positives, and I need to take away, I'm just going to move this up a little bit, I need to take away 56. So just like we do with the number line, students can find comfortable numbers that they like to work with to get them to 56. So my natural thing would be to try to get myself to 40 first. I can add 6 to get to 40. Again, I can add as many 0 pairs as I want. So then I could add 10 more to get to 50, another 6 to get to 56. Again, these intervals are student friendly because students can choose what jumps they'd like to do. So that means I have now taken away my 56 because I have 34, 40, 50, and 6 taken away. And on this side, I'm left with, students can do the math, 22 negatives. So therefore, my answer is negative 22. This method helps students keep track of the negatives. Let's try an even larger number. So let's say we have negative, sorry, we're going to go with positive numbers here. Negative 300. So let me, I meant to say positive 300 here. Positive 300 take away 524. So again, students can write down their chart. We're taking away, so we don't write down the second number. Now 300, and we have to get a difference of 524. So if we added 200 to both sides, 200 zeros, 0 pairs, 500, and I could add 24, 524, so I can now take away the 524 positive, and I'm left with 224 negatives. The beauty of this method is that you can use it with negative integers. So let's say I had negative 7 take away 3. So I have negative, positives, and negatives. So now I'm starting with negative 7. So the 7 goes here on the negative side. And I'm taking away, so I'm removing 3 positives. So that means I need to have 3 positives to compensate. So I need to add positives. I don't have any, so I need a 0 pair of 3 positives. I can take away my 3 positives, and I'm left with 10 on the negative side. That's a 1. 10 on the negative side. So my answer of negative 7 minus 3 equals negative 10. So thank you for tuning into this method. And now we're going to examine and explore what are the pitfalls or advantages of each of these methods.